Alright guys, so we are up to question 3. I did do this question before, but my video stuffed up, so I'll redo this. Okay, the question is, find the volume of revolving this function about the x-axis with the boundaries of the y and x-axis, and that's a little graph that I sketched. Now, one thing when you encounter these questions that you need to ask yourself is this an even or odd function? Now, if you look at the x's, right, if I was to put x equals -1 or 1, I end up with the same answer. And that's true for every positive and negative combination. So because of that, this is an even function. Okay, so I start off at what is the value of when x equals 0. So when I put x equals 0 there, this becomes 1 on square root 9. So therefore it's 1 on 3. That's what I've drawn over here. And when x equals, so the next thing is what happens when x gets larger. When x gets larger, this little bit gets bigger and bigger, and 1 on any positive number goes towards 0, right? So what's happening over here. It's going down, 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 but never goes negative because this square root will never go negative, right? So there's an asymptote at y equals 0. But it doesn't really matter too much because it says it's bounded by x equals 3. But hey, look, it's good to notice. So when x equals 3, y is equal to square root of 9 plus 9. And remember that you can factor out this 9. Okay? But remember, when you're factoring out of a square root, make sure you square root it. Okay? So it becomes 3 root 2. So that y value over there is 3 root 2 at x equals 3. Now, one way that I used to remember doing these questions is it's a cylindrical component, right? So the smallest part is a cylindrical component. It's pi r squared times h. That's the volume of a cylinder. Except my r squared is actually a y squared. Okay, and my height or my thickness is dx. All right, and so a small volume is equal to just this part. To get the entire volume, on the other hand, I have to integrate it between 0 and 3. So x goes from 0 to 3. Okay, so I took my pi out, and I end up, so y squared, I actually end up writing this. Okay, so y squared, all that happens is that the square root goes away, but I'm going to write as 3 squared instead. Okay, it should be obvious as to why I did that, because in the integral table, if you look at your standard integrals and look at this one, it goes 1 on a squared plus x squared integrated is 1 on a tan inverse x on a. Okay, so that's how I end up here. So tan inverse x on 3, and don't forget this 1 on 3 as well. And that goes between 3 and 0. So when x equals 3, this is 1, and tan inverse of 1 is pi on 4. And when it's 0, tan inverse is 0. Okay, so this is pi on 3, I end up with pi squared on 12. Part B of the question, or at least the first part, goes find the vertical and horizontal asymptotes of this. So the vertical asymptote, you should straight away go is x equals 4. Okay, because that's right down here. X can't be equal to 4. Again, the horizontal asymptote on the other hand, what I'm going to do is write this x minus 2 as x minus 4 plus 2. Okay, because I can write this little bit as 1, and then it goes 2 on x minus 4. Now this bit, when x goes to infinity or even minus infinity, it goes towards 0, right? So my horizontal asymptote is going to be 1 plus 0, which is y equals 1. Okay, let's stop there and go on to the second part of the question.